All right, assalamu alaikum everybody. We are live and let's start off. So we are inshallah starting today's class with the revision of what we were studying on Friday. So on Friday we ended the class on this topic related to addition of binary numbers. Where we were basically looking up to how if I have some specific binary number, or if like I say that I'm aware that 7 plus 5 is, let's say, 12. That's pretty simple because we have been studying this throughout our life. But what if someone comes up and they're like, sir, rather than 7, what if I write it in terms of binary? So like 1, 2, 4, 8, right? So what if I say that, sir, you need to add 0, 1, 1, 1 and 0, 1, 0, 1, which is basically the binary equivalent of 7 and 5. How are we going to be adding these two values? Now for 7 and 5, it's pretty straightforward that I just need to count 7, 8, 9, 10, 11, 12, and there we go, we are good to go. But what will I be doing for these binary values where we only have zeros and ones? Now, 1 plus 1 is a 2, I know that. But I cannot do 1 plus 1 as 2 because 2 is not a state that exists for binary. A binary could either have a 0 or a 1. What will I be doing in such a scenario? Now, that's a problem, right? So, for that, what computer scientists did was that they basically came up with some rules. They were like, okay, let's compute some rules which would define how to add these values. So like 1 plus 1 should be this, 0 plus 1 should be this, 0 plus 0 should be this. And just like when we say 19 plus 17, and we like 9 plus 7 is what? 9 plus 7 is basically 16, but I can't write 16 up here. So we do 6 and 1 carry, right? And then we like 1, 1, 1, 3. So the answer is 36. What if we have a carry situation up here? How are we going to be dealing with that? So all of these situations were basically discussed in a set of rules, which the computer programmers describe. And now we are inshallah going to be doing questions today related to implementation of those rules. So now what were those rules? I would recommend that you guys write this down somewhere because when we are going to be practicing आप लोग नहीं जवाब देना, so it's recommended you guys write these rules, and once we start practicing you're going to note that these are like literally very straightforward. So basically let's redo this example. Let me make up the space and then आपको अच्छे से समझ आ जाएगी. Let me remove this. And so the rules which basically we are going to be studying are these. So we need to basically learn that if we have 0 and 1 being added, the answer is going to be 1. When a 1 plus 0 is being added, the answer is also going to be 1. This basically is the opposite of each other, right? So like 0 plus 1, the answer is going to be 1. And just like that, if it was 1 plus 0, the answer would still be 1. So then let's say you have 0 added with 0. The answer is going to be 0. If we have 1 being added with 1, the answer is going to be 0, but we're going to have 1 carry. And finally, if like 1 is being added with 1, and let's say we had a carry up there too, the answer is going to be 1 with 1 carry. Now, I know that might seem like a bit something which might be a bit confusing, but when we are going to be practicing the questions related to this, you're going to see that it's not that difficult. Like for instance, we're going to be dealing with this one question which I have up here. So you just need to follow these rules. So in exam, I would recommend make this chart where you're going to write 0, 1, 1 plus 0, 0, 1, 1, 1, and all this, and it's going to help you a lot. How? Like 0 plus 1. Now 0 plus 1 is what scenario? This one, right? 0 plus 1. 0 plus 1 gives me the answer of 1. So I'm going to be writing 1 up here. Okay, perfect. 1 plus 1. Now, if it's a non-computer science kiddo, they might be like 1 plus 1 is 2. So they would like be, let's write 2 up here. And they're going to write 2, but that's going to be wrong. Why? Because a binary does not have the value 2. It has a state of 1 and 0. So now you're going to learn and go back into your memory and think, oh, sir ne kya rules badhaye the? Okay. 1 plus 1 was basically a 0 with a carry, right? This situation, 1 plus 1 is a 0 plus 1 carry. So now we were going to be writing a 0 up here and 1 carry is going to go up there. Finally, now what's this? It's again 1 plus 1 plus 0. Now we don't have a scenario up here, but it's because we are aware 0 does not have any value, right? If I say 100 plus 100 plus 100 plus 0 plus 0 plus 0 plus 0 plus 0, all these zeros are sort of ignored, right? We know that. So 1 plus 1 plus 0 is again a similar case, just the way we have 1 plus 1, right? Because if I even add a 0 up here, or if I don't have anything written up here, I can write it as 0 plus 1 plus 1. It does not make any sense, any difference. So 0 plus 1 plus 1 or 1 plus 1 plus 0 is going to get me the answer of 0. but with one carry. So there is going to be one carry up here. And then again, if I do 1 plus 0 plus 1, it's again going to follow this condition where it's 1 plus 1 with a 0. And you see that I'm going to write 0 up here, and then I get one carry up here. And if we have something like this up here, I can basically bring this down up here, and my answer comes out as 10001. But now in Friday's class, we had a discussion on how when we have a scenario like this where we were adding 4 bits and the answer came up as 5 bits. So like you see 1, 2, 3, 4, 1, 2, 3, 4, but the answer is like 1, 2, 3, 4, 5, 5 bits, right? So if a scenario like this happens where we exceed the maximum capacity of a specific register, that is basically known as an overflow error. So this is just a recap of what we studied on Friday. If you have an addition or a calculation where the value that is being generated that's greater than the maximum capacity of the register, then the error is basically known as overflow. Now, just keep this in your mind, and then in exam, they might give you a scenario like when we are going to be doing questions today, inshallah. Uske andar there might be a possibility that a scenario like this occurs, and they tell you, bro, now you tell me what type of error occurred, and you just need to name it as overflow error. Say, so let's do a few questions to ensure that we get these rules the right way, and then we're going to move towards the new concept. Now, if you don't understand this, you guys could, I would recommend that you guys should go and watch the Friday's class. This was just a short recap so that you all are aware what we're going to be doing up here. But now let's say a question comes up, practice question, okay? Practice questions. So if I say a question comes up, that's, bro, you need to add the binary 1011 plus 1001. How are you going to be doing this? So firstly, you're going to write the two together. So it's going to be 1011 plus 1001, and they are being added. So now we're going to be remembering the rules, and we saw that if I write it quickly up here, 0 plus 1 is basically 1. 1 plus 0 is also 1. 1 plus 1 is basically 0 plus a carry. And if I have 1 plus 1 plus 1, it's basically 1 plus with 1 carry. Say, so these are like those 4 important rules which you all need to memorize to ensure that you get these concepts. Oh, sorry, मैंने वही बंद कर दिया ना charger. Never mind. So now it came, the name is overflow error. Overflow. So like it's the same overflow when, let's say, you are filling up your water tank. Say, and this is your water tank and it's getting the water up here, and you do not turn off the motor, and what happens is that the water flows out, right? And so we say that the water overflowed, or we say the water is overflowing. So overflow ho gaya. So the same concept is being applied up here, that if the maximum capacity of the register is like this for the water, and we add more water than it can hold, the water is going to come out, right? So it's going to come out, and this basically what we call it conventionally as an overflowing, right? So the same concept is being applied to computer science, that when a value generated is greater than the maximum capacity of that register, the error that occurs is basically known as an overflow error. And if they tell you to describe what's an overflow error, you need to talk about how overflow error is basically an error that is being generated when a value, or when a greater value, when a value is when a calculated value is greater than the maximum capacity a specific register can store. So I will be sharing the notes with you later on, but this is basically your general definition. Okay, so if it's there in your exam, you can write this point. Say, so exam define. So you can write this part if they ever ask you to define it. Now, in order to do this, we're now going to be following these rules, straightforward rules. We just need to implement them. How? So 1 plus 1 is basically what? 1 plus 1 I see is a 0 with 1 carry. So this is going to be 0, and I get 1 carry up here. Then I do 1 plus 1 plus 0, and it's sort of the same concept which was being with the step which we did earlier. So 1 plus 1, even if I have a 0 up here, it does not make any sense or any difference, right? So 1 plus 1 plus a 0 is again 0, but with 1 carry. And then if I do 1 plus 0 plus 0, this is the same thing if I do 0 plus 0 plus 1. So if I'm adding 1 with any number of 0, it's going to get me what? A 1. So I will be getting 1 up here. And then 1 plus 1 is going to get me a 0 based on this rule. 1 plus 1 is going to get me a 0, and I'm going to get 1 carry. And this carry is going to come up here. So my answer is going to be 1, 0, 1, 0, 0. But again, in this scenario, in exam, they won't be giving you a scenario like this. But if you were to add, this might be part A. In part B, they might say that this specific calculation resulted in an error. And now they might ask you, bro, what's the error? And so you should be aware that an error of overflow occurred. Why? Overflow error basically occurred because if you look up at the values which we had originally, how many bits were these? So we had like how many bits? This was 4 bits. Say this was 4 bits. And just like that, this was also 4 bits. So the answer should also be in terms of 4 bits, right? Bilkul Zulkarnain, you're right. But the answer which I'm getting up here is not 4. This is basically 5 bits. So it's more than what the original values were. And so this means that it basically, you can say, exceeded the maximum capacity, which was of 4 bits. And so we're getting an error. But now, if I have to do one question, jo ke thoda sa real case mein ho sake, so we can say that what if I have to add 7 and 4? Let's say 7 and 4. So 1, 2, 4, 8. The binary for 7 is going to be 0, 1, 1, 1. And for 4, it could be 0, 1, 0, 0. If I have to add them, what will the answer be? Let's do that. See, so again, just memorize the rules, and it's something when you start practicing, you're going to automatically know that it's not that difficult. Now, 1 plus 0 is straightforward. 1 plus 0 is straightforward. 1 plus 1 is what? It's 0 with 1 carry, right? Again, same rules. 1 plus 1 is what? 0 with 1 carry. So we get 1 carry up here. And again, 1 plus 0. And if we don't have any other 0, 1 plus 0 is again 1. So you see, I get the answer as 1011. But here, we do not have any overflow error. We don't have any overflow. No, Zulkarnain. The answer is 1011. You don't have to write that 0 ahead. So Zulkarnain basically said that the answer is going to be 01011. No, there isn't any requirement of a 0 being placed up here. When we have a 5th bit being generated, that's an indication that an overflow error occurred if we are adding 4 bits wala. So it's the same way if I'm adding 8 bits wale and 8 bit wala resulted in a 9th bit being formed, then that's an overflow error. Otherwise, if I don't have any carry up here, there is no need to add 0 up here. So the answer is 1011. And now I discussed this even in yesterday class. The answer to this should be 11, right? So if I find the identity of this binary, it should also be 11. So 1011, let's find the binary identity of it is 1, 2, 4, 8. So it's basically 8 plus 2 plus 1. And 8 plus 2 plus 1 is basically 11, which is 100% same to the one which we had earlier on. This also proves that if in exam you ever forget these rules, one other way of doing it is that you can do it through this method, 7 plus 4, and you get 11, and then you just write the binary of 11, and you're going to get marks. But the rules process is basically what the examiner is looking for. So I would recommend that you guys don't follow this method. Perhaps you should go with the rules method and just memorize these rules. And even like till this point, if you have looked at the questions we did, it's not that complicated. It's pretty much straightforward, and it's just implementing the rules which we mentioned earlier on. Let's do one other question of an 8-bit binary value. Let's say I have a number, let's say 64, and I add 36 into it. So 64 plus 36 is basically 100, right? So the answer at the end should be 100. So let's write the binary of 64 first. So 1, 2, 4, 8, 16, 32, 64, 128. So the binary of 64 is going to be 0, 1, 0, 0, 0, 0, 0. And let's make it 102, right? So let's make it 102. This is going to be 1, and this would be 0. And I need to add a 36 into it. So this would be 1, 0, 0, 1, 0, 0. So now if I add them, this is a pretty straightforward question, but if I have to do it, it's basically 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is again 1, 0, 0, 1 plus 0 is 1, 1 plus 0 is 1, and this is 0. But now if I find the identity of this binary, it should be 102. Let's do it. So first I get this, 2, okay, then I get this, 4, then I get 32, and then I get 64. So let's do it. So it's basically 64 being added into this 32, being added into 4 and 2. So we know that 64 plus 32 is basically 96, and 4 plus 2 is 6. 96 plus 6 is basically 102, which is 100% similar to the one which we had originally. This clearly verifies and proves that whatever binary calculation we just performed, that's 100% right. So in exams, you would have enough time. Your paper is of 1 hour 45 minutes, and it's of 1 hour 45 minutes for a reason. So now once you do enough practice, inshallah, over the course, you're going to see that at the end, when you start doing past paper practice, you would be able to finish your paper in 40 to 45 minutes easily, given that you are done with all the course content and you have done ample amount of practice. So once we are done with the paper in 45 minutes, what we are going to be doing is that once you are done with this, you have like 1 whole hour left. And that 1 hour in your exam is not for the purpose of sleeping or maybe looking here and there, or maybe setting up your jacket and giving the feeling or the what do we call it, impression that you are very smart and that yeah by math ho gaya. Or also you don't have to make the mistake that aapne kar liya and you're like okay, invigilator साहब, just here you go, take the paper and let me leave. Exactly, na, I mean, ye nahi karna. You can leave the examination room, but you shouldn't. Why? Because once you complete the paper and you have enough time left, that time is basically going to be used for rechecking the paper. So now when I'm rechecking the paper, I have to basically use such strategies where I'm going to be saying, okay, I got this answer in the first try, but now let me add it up and see whether it's same to the one which I had up there. If it's not, what if it's 101? This means that you made a mistake. And I'm telling you, I have seen this in ample amount of places back when I was giving my CIEs, where I used to make such dumb mistakes in my exams. And so it's something really important for like all the subject, not only computer science, for all the subjects. Stay there till the end, try to see if you made any mistake or not, and so like verify the answers through the methods which I'm teaching you guys. Say, so now this is basically how you're going to be dealing out with positive numbers. So before moving on, you guys should quickly tell me in the chat box, is this clear or not, and let me see if I can find a quick question from some CIE exam. Till then आप लोग मुझे बताओ, is this clear or not? Perfect, perfect, perfect. Zulkanan, clear or not? Quick. Oh yeah, बंद ही कर दिया, my bad. किधर गया? I should have found this earlier on, but chalo. Zulkanan, do you have any question or is it clear? I hope I get a question. Otherwise, okay, we do have one question, but it does not. Okay, yes, we do have a question. Good. We're going to be doing this. See? So this is from your past papers, directly from your actual CIE examination for the summer 2024 papers. Perfect, Zulkarnain. So we're going to be looking into this one question from your exam. Say, so it basically says that you have two binary integers, makes sense, which is this and this, and they're being added together. So you need to add them using binary addition. Now you see this is pretty important. They wrote the term binary addition, which basically means that the one method which I said, that if you add them up 11 and then you can write the 11 binary of 11 and you get the correct answer, even though you get the correct answer, you won't be awarded marks up here. Why? Because they clearly said that you need to follow the binary addition, which means that you need to go through the conventional rule method, which I was talking to you earlier on. 1 plus 0 is 0. Yeah, sure, if you guys want to give it a try, you can quickly just do it. And you have like, let's say 1 minute. Your time starts now. Just give it a quick shot and let me know what answers you all get. अच्छा, आंसर्स भेजने नहीं, आंसर्स को बनाए से तब आप लोगों ने भेज देना सही. So your time starts now. We're going to wait till 9:21. Let me see time, world clock. Okay, so you have like 40 seconds left and it's straightforward. Okay, now that's great to know. Ibrash and Zulkarnain, once you complete it, just let me know in the chat box कि आप लोग कभी हो गया. Try to do this on your own. It's pretty straightforward. अगर नहीं होता, don't worry at all. That's the purpose of the class. So we need to ensure that it's just for the purpose of practicing. And if it's not being done, we will be first solving it on my own, and then आप लोगों ने मुझे बताना है कि आप लोग के answers match हुए या नहीं. But let me write the rules for you all ताकि आप लोग के लिए आसानी हो. 0 plus 0 is basically a 0. 0 plus 1 is basically 1. 1 plus 0 is again 1. 1 plus 1 is basically 0 but with 1 carry. And if I have 1 plus 1 plus 1, that's 1 plus carry. So these are the rules which you might be requiring to solve the question. Okay, Ibrash is also done. Great. Zulkarnain, boss, the moment you are done, just send a message in the chat box. Same. It's 9:21. Chalo, let me start solving. And Zulkarnain, आप अपने answer का जैसे ही हो जाए, don't send it in the chat box and just compare it. No worries, no worries. आप करो and let's start off with solving the question. Zulkarnain, you should do it alongside and let me know if your final answer is similar to the one which I had, which I'm calculating right now. So you see, we have these two binary integers 0, 0, 1, 1, 0, 0, 0, 0, and it's being added into 0, 1, 1, 0, 0, 1, 1, 0. Now, let's follow the same rules which we studied up here. 0 plus 0 is what? A 0. Okay, makes sense. 0 plus 1 is what? 0 plus 1 is a 1. So this is going to be 1. 0 plus 1 is what? This is 1. 0 plus 0 is again a 0. And this is 0, 1, right? Yeah. इसको थोड़ा सीधा इसलिए लिखा करो ताकि आपकी alignment खराब ना हो. The way I wrote it, this is wrong. थोड़ा सा tilt हो गया तो बंदा mistake kar lete hain. Say, so now this 0 plus 1 is going to be a 1, and this 1 plus 1 is 0 with 1 carry, right? So this 1 carries goes up here, and 101 is again going to be this one, 1 plus 1, so it's going to be 0, but we get 1 carry up here, and this 1 plus 0 and 0 is going to get me the final answer as this. So my final answer is 100101110, and this is my final answer. So Zulkanan and Ibrash, okay, and Aya, that's perfect. Baki apne bataya, is this the same answer you all are getting? That's great to know. Shabash, Zabardast. This means you're getting the concept. Perfect, guys. Perfect. Kudos to all of you. This is literally the maximum amount of questions you might be getting from binary addition. इससे ज़्यादा मुश्किल नहीं आता. Now you guys tell me, is this difficult? Like literally, it's one of those easiest ways to get a perfect 3 on 3. So it's like literally very easy to get that A star and a distinction. You just need to be focused. Now, we have studied addition of binary. Now at this point, we will be exploring the concepts of negative number. So like till now, all the binary which we were finding were of positive integers, right? So I had like positive numbers. So if I tell you, bro, find me the binary of, let's say, 37, you guys could easily do it because it was positive. But now if I tell you there is an integer which is negative, which means that if I ask you, bro, that I want you to represent minus 37, how are you going to be dealing with that? How can you represent minus 37? Definitely, it's not the way we are going to be using the way we were writing positive 37, because positive 37 and negative 37 are two different things. So now to represent binary negative numbers, there is a whole method which we are going to be studying right now. So let me write the heading, representing negative numbers in binary. Negative numbers in binary. Now there are basically two ways to representing a negative number. The one method is basically known as 2's complement. Say method 1. Method 1. The name of this method is basically 2's complement. So now in your exam, if they clearly said that find the 2's complement of something, or use the 2's complement method to get an answer or something of that sort, so you're just going to be using the method which I'm sharing right now. And then there is one other method which I personally used to use also. And so if it's not stated, you can also go with that. So for instance, there is a number, let's say minus 37, and I need to find its binary. The approach to finding it is very simple. You know how? You first of all, let me write the steps. Write the binary of positive 37. So we're going to be writing it off positive 37, which we know how. It's just the same way. 1, 2, 4, 8, 16, 32, 64, 128. Let me write it off positive 37. So positive 37 would be 0, 0, 1, and 1 plus 5, right? So 0, 0, 4, 1, 0, 1. So this is basically the binary of positive 37. Now, step number 2 is basically flipping the bits. Flip the bits. Flip the bits basically means make your 0 a 1, okay, and make your 1 a 0. So you just flip the bits because we only have two possible states. So I'm going to make this 1 a 0 and a 0 a 1. So yes, मैं इसको उल्टा कर दूंगा. How this 1 is going to become as like this. 1 is going to come as 0. This 0 is going to become a 1. This is going to become a 0. 0 again is going to get its complementary form 1. This 0 is going to become its complementary form 1. 1 is going to become 0, 1, 1. Now the word complement basically comes from the fact that I say that 1 is basically a complementary to 0 because it's the opposite, right? So मतलब इसके अब काफी आपके पास वो आ सकते हैं complementary sometimes in like those it's said that किसी चीज के साथ free में आना, something like that. But in this context, a complement basically means which I can say that 1 के साथ 0 आता है. Say it's not possible that 1 ke saath 3 hai, 4 hai, 5 hai. That's not possible. So with 1 we only have the complementary as 0, and with 0 the complementary is only 1 because we have two possible states, and that's the approach you all have to use too. So we're just going to approach and we're going to flip the bits, which means find the complementary. Now till this point, this value, this binary is basically known as 1's complement. Say this is important. A lot of people are not aware, but this point where you basically flip it, this is not your final answer, but this is known as 1's complement. See, but now you see we were basically making use of 2's complement. This means that this is not the final answer. Now to get the final answer, we are going to be following the third step, and the third step basically says add 1 into the answer. Add 1 into the answer. which means that whatever binary I had up here, now I'm going to be basically adding plus one into it. So 1 1 0 1 1 0 1 0, and I'm going to be adding one into it, and that will get me my final answer. Now, what's going to be the final answer? I'm going to be using the same rules which I studied earlier on. 0 plus 1 is what? 0 plus 1 is, oh, charger band ho gaya. Okay, never mind. Graphic tablet. Ek it just got disconnected. Okay, it's up here. So 0 plus 1 is what? 0 plus 1 is 1, right? Perfect. So 0 plus 1 is going to be a 1. And then we don't have anything up here, right? So this basically means that it's basically zeros beneath them. 0 0 0 0 0 0. And so this basically means that we are going to be writing the same exact thing up there. Because 1 plus 0 is again 1, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1, and 1 plus 0 is 1. Now this is basically your binary for negative 37. But this is in 2's complement form. 2's complement form. Now you might be wondering, sir, this binary is not of negative 37. What if I write it like this, 11011011, and I find the equivalent denary value of it? It's not giving me negative 37. It's rather giving me a big number like a 128 plus 64 plus 16 plus 8 plus 2 plus 1. And when I'm not saying that you're wrong, there is basically, wa alaikum assalam, Ramin, how are you? Zulkarnain, kya cheez? What, how? How did we get minus 37? Yeah, what? Negative 37. Yeah. Okay. So, उसपे आता हूँ, रुको revise कराता हूँ. Now, if we add these 5 digits, you might be saying, let me do it through the calculator because अभी मैं इसको mental math से करूँ तो उसपे time ज़्यादा लगना है. It's 128 plus 64 plus 16 plus 8 plus 3, right? So, this is basically the binary identity of 219. Sir, we wanted negative 37. So now just to give you a quick recap of what we did, ये मैं आपको बताता हूँ कि negative कैसे आता है. Basically, if I have to convert a specific number, a positive binary number, into negative one, or I have basically a positive integer and I have to convert it into a negative form, like the way I had minus 37, and I need to write minus 37 in terms of binary, how will I be doing that? The process to that is basically straightforward. You first of all are going to be writing the positive binary of 37. So हमें ये तो पता है ना how to write it for positive 37. You're just going to write the same exact thing. जिस तरह हम positive 37 की binary लिखते थे, I'm just going to be writing that. So I wrote the binary for positive 37 up here. Now, basically, we're following the method of 2's complement. Now, in 2's complement, the next step, if I have to find the negative integer, is that basically I need to flip the bits. By flipping the bits, I basically mean that I'm going to convert the 0 into 1 and a 1 into 0, which means that this one is going to become as a 0, this 0 is going to become as a 1. So we just shifted the whole original value complementary. So हमने इसका complement निकाल दिया, like उल्टा निकाल दिया. 1 plus 0, 0 plus 1, 1 plus 0, 0, 1, 0 का 1, 1 का 0, 0 का 1, 0 का 1, right? And now this stage is basically known as 1's complement. Now, when I add 1 into the 1's complement answer, I get the binary of negative 37. So now if I add 1 into this, 1 plus 0 is 1. And definitely if I don't have anything written up here, this means it's basically useless zeros, right? Just come ignore kar dete because I said that you can add zeros at the left hand side. So ab ye hamare paas zeros hai. We're just adding the same exact thing and it's giving me the exact same value as the upper one. And so this binary is basically of negative 37. Now, Zulkarnain, before moving on, kindly let me know, ye samajh aaye ki how we got this 110111111, which is basically the binary of negative 37? Yes, good. Now, but I was basically saying that if I have to look at this binary, you might be wondering, sir, that this specific binary is giving me the answer of 219. Yes, Zulkarnain, do you have a question? Send it in the chat box. Very easy. जो भी questions हो guys, just send them in the chat box. No need to worry because that's the main purpose. The more you ask questions, the better your concepts are going to be. And I really want to emphasize on this one thing that if you're, can we just add the first value with 1? No. It's the, you see the process name is complementary, 2's complement. This means that there is an important step of flipping it. It's the same way, bro. If I tell you that you're cooking biryani, right? You're cooking biryani, and in biryani, you have to, let's say, add tomatoes and onions, and you need to ensure that it's a bit of fried before you add the rice at the end. So आपसे मैं एक चीज पूछता हूँ, is it possible you make biryani without adding your onions and tomatoes? No, right? It won't result in biryani. It might get you some dish, but that's not the one which you're looking for. You're looking for biryani. So the same concept is being applied up here, that you cannot miss any of these three steps, and they of all the three of them need to be followed in the exact order. So ये तो वो वाली बात हुई that have you ever seen a scenario like this where you might yes, Zulkarnain, yes. So I'm just saying that have you ever seen a scenario like this in the last step? Okay, can we just add the first value with one in the last step? In the last step, can you just add the first value? Yeah, you just have to add it with one. So like ये zeros तो मैंने आप लोग के लिए डाले. It's just like this. You just need to add one into it. You just need to add one into it. But because you might be saying that what we don't have anything beneath this, 1 plus 0 is going to be 1. Okay, makes sense. Now, but you don't have anything up here, so it's just for your knowledge that if there is nothing listed up here, you can assume them to be zeros. But in reality, you don't have to add them with like 0 or 0, 0, 0, 0, 1. It's just that you need to add them with 1, 1. And if you don't have anything next to it, it's basically empty zeros. So you just need to follow this step. You just need to add 1 into it. So you can add. Perfect, perfect. Yeah, I get it now. I get it. So now the important point is that if you get this, I know that this is the binary for -37. But if I find it for the denary of this specific binary, it's giving me 219. Now you might be wondering, sir, how is this possible? I need to get the binary. I should be getting the denary -37. But now this is very important. Remember, whenever we get the answer in terms of 2's complement, then if I have to find the denary value of it, your 128 bit or the most significant bit, this bit which is on the most left hand side, this is known as most significant bit, MSB. Or MSB could be, it's not like always stated as MSB, but it's basically your most significant bit. Why is it's your most significant bit? Because it has the greatest value, right? You tell me, in सारे values में से, like this has value 1, this has 2, 4, 8, 16, which one has the greatest value? This bit, right? It has the most value. And so when we write 2's complement and we use the 2's complement method to find a specific answer, the 2's complement basically results in the 128 bit having the value -128. So it's basically that when we make use of 2's complement, your 128 bit no longer has the value of 128. Perhaps it has the value -128. So this means that if I have to now redo it, because we use the method of what? We use the method 2's complement. This means that the final binary up here has the 8th bit as 128, -128. So if I have to do it 1, 2, 4, 8, 16, 32, 64, and now rather than writing 128, it's basically -128. And now if I write the binary of this, it's going to give me the answer in terms of -37. How? Let's do it. 1 1 0 1 1 0 1 1, which means that it is basically trying to say that you need to add what? -128 plus 64 plus 16 plus 8 plus 2 plus 1. Let's do it on the calculator. -128 plus this all is going to be, it's going to be 64 plus 16 plus 8 plus 2 plus 1. It's basically 91. And so now it's basically saying 128, say it's the same thing. -128 plus 91 is what? It's going to be -128 -128. एक से मैं आप लोग के लिए वो कर लेता हूँ. -128 plus 91. And now look up here on the screen. I did -128 plus I don't know, plus 91. And the moment I press equals to, it's giving me what? It's giving me -37, which is the exact value जिसकी मैंने binary find की थी. This means that this is 100% the right answer for -130, -37. So if you are given a specific binary, a denary number, and they ask you to basically convert it into the -2's complement form of its binary, तो आपने ये method use करना है. So here are the steps. Let me write this up here. 2 steps, and you just need to follow these 3 steps, and you're gonna get the right answer. Yes, Zulkarnain. भेजो 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 in the chat box. Sir, are we supposed to write a minus sign with the very first digit? This one, this very first minus 128. Yes, once you convert it into the two's complement form, so like after this flipping part, after the flipping part, not before, not here. यहाँ पे positive है. Why? Because this is basically the binary of positive 37. Well, once I flip it, once I can make the 0 a 1 and 1 a 0, then this 128 is going to be written as minus 128. Say so, like at this point, after 1's complement, this is going to result in 128 becoming negative 128. So like in the second step, this part is no longer be written as 128, it would be minus 128. And the same thing comes up here. This would be also minus 128. Say it. Does this answer your question? Or is there any other question? Okay, नहीं नहीं फिर आप क्या पूछ रहे हो? नहीं नहीं फिर I'm not getting. Like minus 1 with what? Well, एक second. Let me turn on the chat. एक second. वो कर लेता हूँ. Yes, you can turn on your microphone and explain it through that.
सर जो थर्ड स्टेप आपने कराया है ना,
Hmm?
मतलब फ्लिप के बाद जो हमारे पास आंसर आया बाइनरी का 1101101, तो
Zero
इसमें
one.
जो राइट
ये वाला.
राइट हैंड साइड पे नीचे वाला येलो शेड के साथ जो है,
जी जी.
इसके साथ राइट वाले वन के साथ हम -1 लिखेंगे, जो वन -128 के नीचे जो वन है।
Minus 128. यहाँ पे?
जी
नहीं 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 नहीं. You don't have to write a negative
तो सर
sign.
हम इसको सर डिफरेंशिएट कैसे करेंगे, क्योंकि अगर माइनस नहीं लिखेंगे तो वो तो ऊपर 128 ही रहेगा।
नहीं 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 नहीं. See, the thing is, अब basically, Zulkarnain is saying that how are we going to differentiate between this one if it's up here and up here, कि अगर हम यहाँ पे माइनस नहीं लिखते तो हमें ये कैसे पता लगेगा कि ये, like Zulkarnain आपकी ये क्वेश्चन है ना, if we don't write a minus up here, how are we going to understand कि हम ये basically negative form के अंदर इसको डील करें, right? Okay, so basically एक बात ध्यान में रखना, we always have it as 128 positive. से हम हमेशा positive 128 के करते हैं. Computers के अंदर there is this one logic, this one step, that when we flip the values, so like you see यहाँ पे क्या है, it's 0 0 1 0 0 1 0 1. What did I do? मैंने flip किए, right? I flipped them. I made the 1 a 0 and a 0 a 1. So this 1 became a 0 and this 0 became a 1. So when I flip them, it basically has this one ability, and the computer is basically programmed in a way where it tells it that when you flip it, तो आपका जो 128 है, it no longer is positive 128. तो ये negative 128 हो जाएगा. उसके बाद there is no need to write a minus up here. Perhaps whenever we are going to be calculating the value, so rather than having 128 up here, it's going to be something like minus 128. So हमें ये पता होगा, it's not like कि आप differentiate या कुछ करोगे, आपकी differentiating is only going to exist at a point when you're going to be calculating the denary, and because we know कि हमने उसको flip की है, तो rather than having it as positive 128, because I have flipped the values, I would be having a minus 128 up here. And so because I would be having a minus 128 up here, I can literally just put one beneath this, which would indicate कि यार अभी ये जो है ये negative values के साथ deal करेगा, because anything minus 128 plus anything is going to be a negative number. Minus 128 plus 1 is going to be negative 127. Minus 128 plus 2 is going to be minus 126, and so on. It's going to differentiate it. So for us, writing 1 here is not necessary. It's just जो हमें याद होना चाहिए that when we flip the bits and one's complement happens, उसके बाद your 128 is basically going to refer to negative 128. Now is it clear? Now is it clear?
Sir.
Perfect. Okay. So now we have done one method of representing negative numbers in binary, but there is one other method too. And that method is basically the same two's complement method, but a shortcut. Method 2, but this is basically a shortcut. Shortcut. Now, because we are aware that 1 to 4 and 16 in 2's complement, whenever I have to deal with negative numbers, so usually whenever you have to deal with negative number, it's going to lead to 2's complement. Like it's not possible कि आपके positive manner के अंदर कोई answer हो या 1's complement में answer हो. Your negative number are always going to be in 2's complement. And because we are aware that in 2's complement, our most significant bit, or the 128 wala bit, is having the value of minus, so we can also use this one shortcut. जिसके अंदर if I have 1 2 4 8 16 32 64, and minus 128, I can directly put 1 beneath all of them, which when I add them, I should be getting the negative answer. Like for instance, I want to find the binary for negative 57. So what I can do is that because I want to do negative 57, एक तो मेरा 1 यहाँ पे आएगा. Because if I don't put 1 up here and I do all these other, like let's say I do something like 0 0 1 0 1 0 0 0, the answer to this is basically 32 plus 8, 40. But now this 40 is positive, but remember this is in 2's complement form, 2's complement form. So if you get a positive answer in 2's complement form, that's also possible. But now if I have to represent a negative number, so for that the logic is going to differ in a way कि यहाँ पे जो मेरे पास 128 वाला bit है, this is going to be 1. So this means that minus 128 will be added with something, let's say x, like maths or x. Okay. So minus 128 should be added with something so that my final answer is what? My final answer is minus 57. Now let's do a bit of maths. So if I shift the value, if I shift this 128 to the other side, this means 128 is going to become positive, and 128 minus 57 is going to be what? Let's do the subtraction. 128 and I have to subtract 57. So 8 minus 7 is 1, and I cannot do this. This is going to become 0 and 1 carry up here. So 12 minus 5 is what? 12 minus 5 is 7. So I get the answer as 7. T1. So now if I put 1 up here beneath all these values, that's going to get me a 71. I should be getting the exact binary of negative 57. How? Like let's say यहाँ पे मैंने 71 को represent किया. I'm going to put 1 up here, and 64 के अंदर what will I be adding to get a 71? I should be adding a 7, right? So this is 0 0 0 4 2 1. So this binary is again the binary for negative 57. What I did was कि मैंने ये find किया that okay, I have minus 128, and now I need to definitely add something into this negative 128 to get negative 57. So I just made a small mathematical formula, minus 128 plus some number. When I add them up, I should be getting minus 57. So what will be the value of x? It's going to be this minus 128 is going to shift to the other side, and it's going to become 128. And so 128 minus 57 is going to be 71. This is basically a shortcut method to the longer method which we were discussing earlier on. But now if I have to do it the same way which I did earlier on, so using method 1, so if I have to do it, I have this negative 57. I'm going to be writing the binary for positive 57. So it's basically 1 2 4 8 16 32 64 and 128, right? And I need to do it for positive 57 originally, which will be what? 0 0 32 plus 16 is 48, and 48 plus 8 is what? 48 plus 2 and 56, and then 1 57. So this is basically the binary for positive 57. And now we studied it earlier on that if I have to find the ones complement, I'm going to be flipping them, right? So this is going to become flipped, and this 1 is going to become as 0, this 0 is become 1, 0 is going to become 1, this is going to become 0 0 0, and these two are going to become 1 2. And now I'm going to be doing what? I would be basically adding plus 1 into it, so that I get the final answer. Now, if I add 1 into this calculation, I'm getting 1 1 1 0 0 0 1 1. Now, this should match the one which I had. Okay, ये तो plus 57. This should basically match the one which I get up here. So let's compare them. 11 000 000 111. 100% identical to the one which I have up here. You see, 11 11 000 000 111 111, which hence verifies that our answer is going to be the same through whatever method I go. So if I want to use the shortcut method, which I used to do, or if I want to go through this longer method, I personally would prefer कि अगर आप लोग ने करना है, go through this longer method, because examiner would be looking for this flipping part and would be expecting you guys to basically follow the whole set of steps. So, but if it's a shorter question, you need to do it quickly, you can also use this method. And also if you basically get your answer through this method and you do have time at the end, the way I was talking about earlier on, so you can basically verify your calculations through this method too. Now before, what's the point of finding x? Okay, good question. So Zulkarnain, you tell me one thing, that if I have a negative number, let's say I have some value negative 70, and I need to get the answer as negative 30, what will I be adding up here? वैसे आपके ख्याल में से मैं क्या करूंगा? What will I be adding up here? I would be adding what? I would be adding some positive number, जिससे जब मैं minus 70 को subtract करूंगा, तो I should be getting minus 30. And that's going to be what? It would be basically minus 70 plus 100 is going to be, it's going to be 70 minus, it's going to be 40. So if I do a calculation on calculator where I add 40 into minus 70, I get the answer as minus 30. Now we are well aware that ऊपर जाके if I have to represent, let's say ये minus 128 कर दिया, this gets this minus 128, but now I need to add something into it, right? I need to add something into this x. I need to add something into this minus 128 so that my final answer is minus 57. So what's that x going to be like? अब यहाँ पे मैं आपको बोलूँ bro, you need to represent minus 57. So आप तो सोचोगे okay minus 128 कर दिया, what other one should I be putting up here so that I get the final answer as minus 57? So like if it was positive 57, it was pretty straightforward. आप one वहाँ पे add करो, but when you add them you get 57. But now because we are dealing with minus negative integer, it's a bit different. So for that, a shortcut which I came up with is that you basically create this small mathematical equation. You say minus 128 plus x should be the answer which I need. So minus 57. So this 128 shifts there and you get 128 minus 57. Okay. And so when you do 128 minus 57, you get the answer as 71. And so when I get the answer as 71, I'm just going to be deploying 71 in all the other parts. So ये एक तो minus 128 आ गया, but उसके बाद 71 की अब मैंने बाइनरी यहाँ पे वो कर देनी है. So when I add these figures up, I would be getting minus 57. Now let me do one example, and here I hope you guys are going to get it in the right way. Let's say I need to represent minus 78. I need to represent minus 78 using shortcut method. I know that in shortcut method, I would be first of all writing the values, right? So it's going to be 1, 2, 4, 8, 16, 32, 64. And because it's a negative number and I'm using the shortcut method, I'm well aware that the most significant bit would be minus 120. Now, because I'm representing minus 78, to get a negative number, this has to be 1 at all costs. So एक तो मेरे पास यहाँ पे 1 आ गया. But now अब मैं यहाँ पे कहाँ पे 1 put करूंगा so that I get the answer as minus 78. It's pretty difficult, right? Because I have to do a longer calculation. So what I do is I create a mathematical formula and I'm like, okay, I have minus 128 and I need to add something into it. So I need to add something up here so that I get my final answer as minus 78. Because at the end, all of these values, जहाँ पे भी 1 होगा, they're going to add it up, right? So minus 128 plus something is going to get me a minus 78. Now what should be that something? Let's put an variable x up here. And so now if I have to find the value of x, this 128 goes up there. And so I'm doing 128 minus 78. So if I do the calculation, 128 minus 78, this is going to be 0, and 7, this is going to be 50. So this means that the value which I need to plot up here is going to be of 50. So minus 128 plus 50 is basically negative 78. So I need to deploy 50 up here. How will I be doing that? A positive 50 ko karo, positive 50 the way we have been doing it before. 32 plus 16 is 48, and 48 plus 2 is 50. So this right now is basically the binary value of your negative 78. And this is the maximum. बिल्कुल perfect जुड़ करना है, बिल्कुल. This is the exact method which you all need to follow in your exam. This is the shortcut method. And if I have to go through the normal method of 2's complement, it's basically you need to find the binary of positive 78, then you flip it up and you add 1 into it, and you're going to get the exact same answer. Like for instance, if I have to practice it with you guys, let's do it too before ending the class ताकि आप लोगों की थोड़ी practice हो जाए. 1 2 4 8 16 32 64 and 120, because I'm writing for originally for positive 78, right? So positive 78 would be what? 0 and 64 plus 14, right? So 14 14 8 plus 4 12 plus 2. This is basically of positive 78. So yes, Zulkarnain. Sir, after doing this, are we supposed? No, you are not supposed to prove your answer. Now, if in exam they clearly ask you to use the 2's complement method, फिर तो आपने ये method use करना है, which I am doing right now. But now let's say you complete the paper in 45 minutes and you have like a full hour left, and you are just sitting there wondering, अब मैं क्या करूं? तो उस दौरान these alternate methods which I'm teaching you guys should just use them to cross check your answers to ensure that whatever answer you're getting, it's 100% the same which you originally wanted. सही है? So ऐसा ना हो कि आपने कहीं तेजी में गलती कर दी. It may seem like you are doing it the right way, but what if you messed up? So when you get a different answer from 2 methods, it's a quick check to let you know that okay, I might have made a mistake somewhere. So now I have this for positive 78. अब क्या होगा? I would be flipping them, right? So I would be doing the flip part. Flip. So if I have to do the flip, this 0 is going to become as 1. This 0, this is going to become as 0, 1, 1, 0, 0, 0, and this is going to become as 1. And now in the third step, I'm basically going to be doing what? I would be adding a 1 into it. So now if I add 1 into this, I'm going to see that 1 plus 1 is basically a 0 with 1 carry. Oh, yahan pe nahi. 1 plus 1 is basically a 0 with 1 carry. And now 1 plus 0 is going to be 1. because I definitely have a zero up here. And then again, because I have a zero up here, this would be zero, this would be zero, 2, 1, 1, 0, 1. And now let's compare it with the original answer which I get up here. This is 1011, so 1011, 0010. 0010. So you see, I get the exact same answer. It 100% matched, and this is now a good proof that if I in my exam I use this method, this is basically my original two's complement method, which you all have to use. But in later on, you do have enough time to many shortcut ये वाला भी use कर दे to verify whether the answer which I'm getting it's 100% correct or not. Now, if the two don't match in exam, they won't ask you to prove or verified. But let's say if you wanted to cross check your answer, so this is the exact method which you all need to follow. Now, before ending the class, I want you all to quickly let me know, is this whole concept regarding negative number and this positive addition and negative binary values being subtract, अच्छा binary की एक चीज रहेगी वो हम कल कर लेंगे. Let me write it up here too. If I have to do addition or subtraction of binary values, that is a very easy topic, but we're going to do that tomorrow inshallah, and we'll be starting the next part too, addition slash subtraction of binary, negative binary, subtraction of negative binary. Now, in your book, the whole concept has been discussed in two ways. One is very difficult, जिसके अंदर इन्होंने rules बताए हुए हैं. And I don't want you guys to spend time on memorizing those useless rules, because why are you just spending time on what do we call it, memorizing useless rules? You're going to be going through some easy shortcuts जिसके through आपको marks भी मिल जाएंगे, and the chances of making an error are pretty low, because we do not want to make mistakes. That's so great to know, Inaya, and that is very important. This is one concept which is being frequently tested in exams. So if you haven't done this in school, it's really important कि आपको ये अच्छे से समझ आ गई हो. So, Ibraj, can you also confirm whether you get the concept, or if there are any questions, guys, you don't need to hesitate at all. Just send them in the chat box, because that's again and again I'm emphasizing that the more questions you ask, the better your concepts are going to be, and the greater the chances are that you get that distinction. That's perfect. Now, before ending the class, I wanted to discuss one important thing with you. Whenever you're preparing for any syllabus exam, say, so let's say it's computer science, like in my case, or maybe you might have been preparing for physics or chemistry or whatever exams out there, it's really important that you go through the syllabus. So going through syllabus has to be the most important thing out there. So whenever we are going to complete a topic, it's your duty if you want to print the syllabus. Otherwise, if you would, I would recommend just go through the syllabus digitally, but you should always go through the syllabus once we complete a specific topic, and maybe chapter complete ho gaya. I'm going to ensure that I also go through the syllabus in the class. But if let's say we don't get the time, it's your duty to go through the syllabus, and you're just going to go and you need to read कि हमने क्या कुछ किया है, did we miss about something. So like I opened up this syllabus, Cambridge IGCSE syllabus in front of you. I hope you guys can see the screen. Sorry for that. You're going to go down, and up here, this is the best guide one can get. Say, so it's literally so helpful कि आपकी सोच है. So you're going to be basically coming up here, and यहाँ पे you need to look up here. This is chapter number 1. So we started off with chapter number 1, which is data representation. So data representation means you all are going to be studying all these things. So candidates should be able to do all this. Now we're going to do this in class too, so that we are aware कि हमसे कोई चीज miss ना होगी हो. But still, I would recommend you all should also go through them. Why? Because sometimes what if I miss out on something, and also alongside that there are these notes and guidance, which are basically the ideal and the best perfect notes you might be requiring. So perfect notes, because these are the exact examiner words. So if there is something important, something is not important, what things are crucial, everything has been stated up here. Say, so now let's go through them quickly in the next 5 minutes कि हमने अभी तक क्या पढ़े and what's left before ending the class. That's so great to know, Zulkarnain. That's so great to know. This is an habit. This is a habit which I even emphasize in one of my videos, that because I revised the syllabus so well for my CI exams, I was 100% sure that this was one question which I felt like was out of course. Now, you might be wondering, how did a question come up out of course in your CI exam? That's not possible. But luckily it did. It's basically said that write three states, or like circle three possible functions of a specific feature. And in our syllabus and in the course book there were only two, so I was very much like sure, not, you can't say sure, but I had this in my mind कि भाई syllabus में दो थे, book में दो थे, how come then the exam test me on three? And luckily when the examiner marking scheme came out like after result, I had a look on it and it clearly said that there was a problem with that question, and so a grace mark was awarded to every student, which means that I was correct. Say, so it's again due to because I was going through the syllabus. So it's something do for, or do this for all the subjects, whatever subjects you're going through, it's like very crucial. Let's see. Did we study this? Understand how and why computer use binary to represent. So all any form of data needs to be converted to binary to be processed by computer. Why? Because the computer is basically made through logic gates and logic circuits. So the same logic circuits, and it's being stored in registers which can only be having two possible states of binary. So then we studied what's binary, binary, and hexadecimal number system. We understood how it's base 10, base 2, base 16 number system. Then we basically looked into the conversion between positive denary, positive binary. We did this. We did how we can convert positive denary and positive hexadecimal, and how positive hexadecimal and positive binary is being dealt with. So basically we saw how we have values be used only in integer, and it could be like in both the directions, and maximum binary number length is of 16 bits. Okay, so this was one point. Chalo, ab dekh liya. That's the benefit. Now I missed upon this one point. When we are going through this in the class content, overlooking the syllabus, we can identify such points which I might have mixed up. So now this is one point you all should be aware, that if a question comes up on what's the maximum binary number length, so it's basically of 16 bits. So in your course, the maximum, like it's not like maximum hogi itni, but in your course, the maximum binary number which might be given to you is of 16 bit. Like we have seen 8-bit values, we saw 12-bit examples, right? 8 bits ka matlab hai 0 1 1 0 1 1 0 1. Calculate the binary of this, denary of this. Or we also saw how we might be given a 12-bit one, 1 1 0 0 1 1 0 0 1 0 1 0. This is 12-bit. And just like that, there is also a possibility they might give you a question which is really tested, but it might be of 16 bits. So it could be like 1 1 0 0 0 0 1 1 1 0 1 0 0 1 0 1. Now this is basically 16 bits. So you should be able and capable of dealing with questions up to 16 bits. But even though that's the maximum length, it won't be tested that often. But the purpose of listing it up here is that आपने जरूर न जरूर एक जगह पे ये करना ही करना है, where you are aware of 16 bits too. So it's really important कि आप ये 16 bits का ख्याल रखो. At least try to do one or two questions so that you are aware that यहाँ तक तो 128, then it's 256, 512, 1024, 2048, 4096, and like I'm telling you, 16 bits is rarely tested, but because it's there in your book, just keep a look at it so that you should be a bit aware of it. So then we basically saw how and why hexadecimal is being used, what areas are it's being used in. So we saw all of those parts. We also saw how it's basically a shorter representation and it is something which is easier for humans to understand. So we are done with this part too. Then we went on to how we can add two positive 8-bit binary numbers, something we discussed today. And we saw that if a value is greater than 255, it's going to result in an overflow error. Now what does this 255 mean? It's the same thing. Like if I have a specific 1 2 4 8 16 32 64 128, so if a value exceeds this and I have like 1 1 1 1 1 1 1 1, this basically is of 255 value. So now if an overflow error occurs, which means that a bit comes up here rather than staying within this limit, this means that whatever answer I'm getting, 1010110101, whatever it is, it is basically greater than the maximum capacity. So this 255 is basically the max capacity of a 8-bit. Max capacity of a 8-bit register. So just keep this in your mind that if they ask you a question, what's the maximum capacity of an 8-bit register, you should be able to tell them that it's basically 255. But we also said that a computer device has a predefined limit. Okay, so like we already saw that, okay, you have 32 bits processors, 64 bits, and basically what's the logic behind having 32 bits, 64 bits? Is basically indicating the maximum size of a register. So like the scenario which we were dealing with in our questions, we said that the the predefined limit was of a 4-bit register, right? So we were only catering with 4 bits. So like if a bit resulted in a fifth bit, that was an overflow. So the same question point is being stated up here too. And then it says that an overflow when a value outside this limit should be an overflow errors occur when a value outside this limit should be returned, which basically means an overflow error occurs. Which basically means that if a value is within the range of 0 to 255, if a value is greater than 255, like let's say 300, this is basically going to be returned, and this state causes the overflow error. So even if you go and give it a read, it summarizes a lot of crucial concepts really well. So आप ये खुद भी पढ़ लेना बाद में, so that you get everything, and if there is anything which is not clear, you guys can always reach out to me. So ये थोड़े points है, ये भी पढ़ लो. An overflow error occurs when a value outside this limit should be returned. So ये भी आप लोग ने कर लिया, सही है. And उसके बगैर okay, graphic tablet क्यों disconnect हो गया? Okay, so yeah, we studied all this. Here we also looked into point number 5, where we explored how we can perform logical binary shifts on a positive 8-bit integer, and the effect it has on the positive binary integer. So if you remember, we discussed this in great detail in Friday's class. And so if you do not get it, you should go watch that. And we studied how to perform left shift, right shift, multiple shift. का ये मतलब है कि 2 times आप logical shift कर दो, and how when you shift from the end of the register, bits are lost and zeros could be added in the opposite, like left hand side. And like if you do a logical shift left, it basically results in the value getting multiplied by 2 or divided if you shift towards right hand side. And like how the most significant or least significant bits are lost, which basically means that if I'm performing a 0 1 0 1 and I do a left shift, so at this point this is my most significant bit, right? Why? Because this has the greatest value. So if I perform this one is going to come up here, this 0 comes up here, this 1 comes up here, and on the starting position we get a 0, but this 0 is ignored. So it's basically that the most significant bit or a least significant bit, if I perform the right shift, they are lost. So ye bhi humne kar liya. And then in today's class we also saw how we can conduct 2's complement to represent positive and negative 8-bit binary numbers. So positive का भी मैंने बताया कि like if I have to represent 40 in 2's complement method, even in that way we would have the -128, but that would be turned as 0, like the way I stated उधर notes के अंदर एक example मैंने अभी कराई है. So उसके बगैर you should be aware how to convert a positive binary or denary into a 2's complement 8-bit, and also the other way around. So we did both of them, and we also going to be looking into how if we have a negative binary or denary integer to a 2's complement. Okay, but इसके अंदर we did not study how if I have a positive or negative binary, how will I be converting that into the equivalent denary. We're going to be looking that in tomorrow's class, inshallah, alongside ye bhi kar dena, and also conversion. Let me write it up here. Conversion between negative binary to denary, so that आपको ये भी अच्छे से समझ आ जाए. So once we are done with these two concepts, we would be basically done with chapter number 1.1, which means inshallah that in tomorrow's class, hopefully, we are going to be starting off with chapter number 1.2, which means that we are done with almost 30 to 35% of our first topic. Now, is this clear, guys? I hope it's super clear. But if you guys have any questions, just let me know. And I would also paste these notes which I made up here in the official notebook tool, so that if you're looking at them later on, आपको उस वक्त भी समझ आ रही हो. So do you guys have any questions? Let me paste this up here and then I will get to your questions. Just a minute. This is image number 1, and let me see if in there. Okay, perfect. If there are no questions, that's it for today. Then inshallah, we can end the class right now, and inshallah see you guys tomorrow at the same time. We're going to be starting off with the concepts जो कि हमने आज नहीं cover किए, and we're going to look into that. The notes will be shared inshallah in the class group on WhatsApp, and if you have any question, you can reach out to me, and I'm also going to be adding you all into क्या कहते हैं, to the Google Classroom platform. You guys could just watch any leftover recordings over that. You're going to be getting a mail. So once I send a message in the chat box, आप लोगों ने अपने mail में चले जाना, and you're going to get a proper access. उसके बगैर, let me explain and give you guys a quick short overview of how that portal is basically managed. So you would be added into something like this. Let me screen share it. Yeah, so you would be given access to a portal like this. So yeah, and इसके अंदर what you're going to be doing is आप जाओगे classwork के अंदर, and in classwork you're going to find all these topics जो कि अभी तक कराए गए. So you would be having all these videos. You can click on that and it's just going to get loaded. So आप यहाँ से चले जाएंगे and it's going to link this open this part and you can watch the video and it's going to start up. साथ में I'm not sure if I'm only getting this summary part because I have Gemini Pro, but if it's there you can also see and have a look at these notes, what do we call it, short summaries. And so बस इस तरीके से आपके वो होंगे. And if you do not get anything you guys can still reach out to me, and apart from that ma'am Naiba would be reaching out to you and perhaps should have reached out. And जो भी आपकी fees related problems होंगे you have to share it with her. She's going to deal with that, and inshallah by the end of next week you all would also be given the access to the conceptuals portal. So you would be having access to both Google Classroom at my end because it's a bit convenient, and at the same time the resources would also be shared at the conceptuals portal. So either way, whatever portal you use, it's there for your own convenience, and you guys can always reach out to us if you need any help. So yeah, so let me just end up the recording, and that's all for today. See you guys tomorrow. Allah Hafiz.